Hello, first and fourth hour algebra students. We're ready to start section 9.5, Inequalities in Two Variables. Before we add some new information into your database, let's make sure the stuff that's already there has been categorized and networked. So what I'd like to do is take a minute to review and compare the types of answers to the questions we asked so far. That's what my goal was on that last slide of yesterday's Padlet. So here I have several equations and inequalities I'd like you to interpret. Each time I saw the word equation, I highlighted it with yellow. In math, the opposite of equation should be inequation, but instead it's called an inequality. So I've highlighted those in a nice shade of teal. Our first one, I'm looking at x plus 2 equals 6. And before you jump to the answer 4, I'm absolutely sure you know that the answer is 4. I want you to think for a minute, not about the answer, but about the form of the answer. When you see an equation in one variable, your answer will always take the form of x equals a number. If we want to do the work, we have x plus 2 equals 6, subtract 2, and we get x equals 4, a number. 4 is the specific answer to this question, but searching for the one number that makes a true statement is the generic work that you do every time you see it. Let's look at the next one, an inequality in one variable. That's a fairly new concept. So before you jump to the answer, x is greater than 4, let's stop for a minute to think what we're looking for. Our answer, unlike the first one, where we're looking for the one mysterious solution, the only one mysterious solution that will solve the equation, we're looking for lots, tons of answers that will solve this. And so as we try to express our answer, we talk about the whole range that the answer can take. 4 is our smallest answer, and negative and positive infinity is our largest answer. All the numbers in between them are also counted as answers because they make the inequality a true statement. Well, actually 4 is not an answer. We want to get as close to 4 as we can. So for example, 4.000001 all the way up to infinity. So for an inequality, the form, to capture all those possible answers, the form of the answer is expressed in interval notation. Good with an equation in one variable, there's one answer. Good for an inequality in one variable, there's lots of answers. Let's look at an equation in two variables. What is the form that the answer takes? Now when we look at this, I know a lot of us are thinking, let's get busy and let's do the work. Well, let's get busy and let's do the work. X plus 2y equals 6. There's a lot of things you can do for that. You can look for x and y intercepts, you can look for slope, but the most common thing is to solve for y. So let's subtract x from both sides, and we get 2y equals negative x plus 6. And when we divide everything by 2, we end up with y equals negative 1/2 x plus 3. That's not an answer. That's actually just another way to express the question. When we look for the answer takes the form of ordered pairs. We're not looking for the one mysterious answer that makes it true. We're looking for the relationship of two numbers that always solves the original equation. The way that we express this is not with interval notation. We express it with a set of ordered pairs, and that set of ordered pairs looks like a line. All right, number 1, we're looking for one answer. Number 2, we're looking for a range of answers. Number 3, we're looking for a set of ordered pairs. Let's look at the next one, two equations in two variables. What does the answer look like for something like this? The answer to this is a lot of ordered pairs. So many ordered pairs, in fact, it takes a graph. The answer to this is also a lot of ordered pairs. When we're trying to solve two equations in two variables, what we're doing is we're trying to find the ordered pair that exists on this line and on this line. We had three ways to figure out how to find that ordered pair. The first was to graph, and we would find the intersection, and then we would write the one ordered pair. The second way was to substitute. If one of them was solved for x or for y, we would just substitute what's on the other side of the equal sign into the second equation. And the third way, which I bet when you looked at this was the way that you wanted to do it first, was to do the elimination method, where we add them together and eliminate one of the variables. If you'd like to, you can take a minute to find out what the answer is. The ordered pair, the one ordered pair that exists on both of them, and then you'll have your answer. We're ready to start exploring the idea of the next thing that we're talking about today. We want an inequality in two variables. Well, it does have something in common with the second one, an inequality in one variable, and that there'll be lots of answers. And it does have something in common with the third one, an inequation in two variables, where there'll be lots of ordered pairs. So let's think about this for a minute. Let's try to guess some answers. If we can come up with three answers, I think that we'll understand what we're looking for, and then we'll be able to come up with all of the answers. I'm looking at the original equation, and I see that it's an inequality. So I'm not trying to get exactly at 6. I'm trying to get at something that is greater than 6. Here's my first guess. The ordered pair 100 and 1 makes a true statement. Why? Because when I put 100 in for x and 1 in for y and add them together, it's definitely bigger than 6. Let's see if we can think of another answer. How about 20 and negative 10? If I put 20 in for x and negative 10 in for y, oops, that's definitely not greater than 6. That's not an answer. Let's try for something else. How about 7.2 and 1.5? If I put 7.2 in for x and 1.5 in for y, yep, that checks out. It definitely is bigger than 6. Here's an answer. Here's an answer. That's not an answer. You can see how random this is. We're going to have to find another way to be more specific to capture all of the possible answers and make sure we don't include any ordered pairs that don't satisfy that inequality. Open the next video and we'll talk about it some more.